Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 8, Section 1, the Pythagorean Theorem and its converse. So we start out with the Pythagorean Theorem, which you should be familiar with. It says, in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So if we have any right triangle, just a little notation, the sides that form the right angle are called the legs, and the side across from the right angle is called the hypotenuse. And this says if we square the legs, add them together, that's equal to the square of the hypotenuse. So we have some special numbers. They're called Pythagorean triples. Pythagorean triples are a set of non-zero whole numbers, so no fractions, no decimals, no radicals, such that a, b, and c satisfy the equation a squared plus b squared equals c squared. So they all have to be whole numbers that satisfy that. I wrote down some common Pythagorean triples, so 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41. I highly recommend that you know 3 of these, and you can't say like 3, 4, 5, and then 6, 8, 10. You can always take any of these and you can multiply each number by a factor and you can get a Pythagorean triple. So if I multiply 3, 4, 5 by 2, I get 6, 8, 10. That's a Pythagorean triple, but it's not considered a different Pythagorean triple. It's considered a 3, 4, 5 doubled. Okay, so I highly recommend you know 3 of these unique ones, not multipliers. So if I want to, for this example, if I want to find the hypotenuse, does it form a Pythagorean triple? So I want to see if I take 20 squared plus 21 squared, what do I get? So this is 400 plus 441 equals c squared. Add those together, I get 841 equals c squared. Take the square root of that, and I believe we get 29. I get 29, so C equals 29. So, yep, this is another Pythagorean triple, 20, 21, 29. So a quick little example. We've got the park department rents paddle boats at the dock near the entrance to the park to the nearest meter. How far is it to paddle from one dock to the other? So for this example, I want to do 350 squared plus 250 squared equals c squared. Now, if I said you're allowed to write your answer as an estimation, this would be great. 350 squared plus 250 squared, add them together, take the square root, rounded answer is great. If I said leave this answer in simplified radical form, this would be a very difficult problem to do. Not very, very difficult. But you're going to square them, you're going to add them together. Now you have to look for common factors. It's going to take a little while. So what I'm going to do is I'm going to look at my numbers. And I'm going to see, is there any common factors that go into both of these numbers? I see 50. This is 50 times 5. And this is 50 times 7. And so what I can do is say, well, this is 50. Actually, I want that to be red. This is 50 times C. So what I can do is I can do the Pythagorean theorem on just the 5 and the 7, and then I can take my answer and multiply it by 50. And that's a lot easier, especially if the problem says leave your answer in simplified radical form. So I can do 5 squared plus 7 squared equals c squared. 25 plus 49 equals c squared. Add those together, 74 equals c squared, c equals root 74. And now I just have to remember that my answer is 50 times that. So my answer is 50 root 74. Okay. And since this is meters, meters. Now, I encourage you to do that. Do the work by hand. Don't put it in your calculator. In this case, often when it's a word problem, we want a simplified radical answer. So I am going to put 50 square root 74 and I get about 430. I'll round to the nearest meter, so that's fine. Meters. So again, I could have done this problem since it said round to the nearest meter just by doing that, putting in my calculators. But especially in the next few chapters, you want to be comfortable working with numbers exactly and then only at the end putting it in your calculator. Okay, the better you can do that, the better off you'll be. Now the converse. So just like all the other converses we have, the Pythagorean theorem says if it's a right triangle, a squared plus b squared equals c squared. The converse says if you can take two sides of a triangle, square them and add them together, and that's equal to the sum square of the third side, then it's got to be a right triangle, and you have your legs and your hypotenuse. So if the square of the length of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is right. So this is used to prove right triangles. You can actually use the converse. So I give you an example. Is this the right triangle? My question is 13 squared, take the smaller sides, plus 84 squared equal to 85 squared? So 13 squared plus 84 squared, that gives me 7,225. And then 85 squared gives me 7,225. Check, right triangle. Now, the next two you might have seen, you might not. I like to think of these as like Goldilocks and the Three Bears. So let me read it to you and I'll explain what it is. It's basically the Pythagorean inequality theorems. So what happens if a squared plus b squared is not equal to c squared? Well, if c squared is greater than a squared plus b squared, then the triangle must be obtuse. And if c squared is less than a squared plus b squared, then the triangle has to be acute. So here is where I kind of think of Goldilocks and the Three Bears. So if c is too big, then what's going to happen is when you do c squared, it's going to be too big for a squared plus b squared, and then we get something that is obtuse. Your hypotenuse is too big. When you square it, it's too big for the other two sides. And if c squared is too small, then you get an acute. C is too small. When you square it, that's too small for the other two sides, so this is too small. And then, of course, if you get it works out perfectly, this is just right. So the question I always have is the hypotenuse too big, obtuse? Is it too small, acute? Is it just right? It's a right triangle. So be cute if we could call this like the Goldilocks theorem, but that would just be my choice. So an example you might be given is, here's three sides. Is it acute, obtuse, or right? So what I'm going to do is I like to start with what would be the hypotenuse. So 14 squared, and then I compare it to 6 squared plus 11 squared. So, I'm terrible. 196 compared to 36 plus 121. So 196 compared to 157. And so you see that in order to make this true, this has to be a greater than sign, which means my hypotenuse is too big, which means that it's obtuse. And that's it for today's video. Thank you for watching. Have a great day.